Okay guys, I'm going to go over some of these. That way if you need to stop and rewind or watch it over, you'll have a video of the recording and not just one shot with the answers. Also, what may be easier is you pulling up your worksheet, and as I'm saying it, you might want to check your answers that way. Whatever's easier for you. Whatever you guys feels easier, that is fine. Okay, let's begin. Okay, so vanadium has 23 electrons, and just like we always do, you start at the beginning of the periodic table. So it's right here, and you know this is your S block, your P block, your D block, and your F block down here. And then we have 1, 2, 3, 4, 5, 6, 7. D's are always one less of what we think. F's are always two less. So this would be a 1s2, a 2s2, a 2p6, a 3s2, a 3p6, a 4s2, and a 3d3. When you add these up, they should equal 23 electrons. When I say add up, I mean the superscripts. And you could see right here that this is D1, this is D2, this is D3. So you knew ahead of time that it was going to end in D3. Chromium is 24 electrons. So it's going to be a 1s2, 2s2, a 2p6, a 3s2, a 3p6, a 4s2, and a 3d4. Now, we learned about the exception on Friday. You cannot end in D4 or D9. This is only for the D block, and it's only 4 or 9 electrons. So what you do here, you take one from your last S, and you add it to the D to make 5 or 10 in the D. So what I like to do is just cross that out, and then fix it. So 4s1, 4d5. So this would end in 4s1, 4d5. Copper is 29 electrons. So this is a 1s2, a 2s2, a 2p6, a 3s2, a 3p6, a 4s2, a 3d9. Let's add them up. 10 plus 10 plus 9 is 29, but then I see that I have a D9 here. I can't end in D9. So that means I have to take one from the S. So this is going to be ending in 4s1, 3d10 instead. And I see that up above in this guy right here, I put 4d5 instead of 3d5. I apologize. All right. So hafnium, that is a huge one. So it probably took you a while to find it. And if we look, it's down here somewhere. Hafnium, hafnium, hafnium. I can't even find it. Ah, 72. Here it is. All right. So you know that it's probably going to end in a D2 right there, because this is D1 and that's D2. So let's go ahead and start. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. I'm going to start writing them down here. 4d10, 5p6, 6s2, and then after the 6s2, remember you go right down here to these 4f14s. So it's 6s2, 4f14, and then 5d2. So let's add them up. 10 plus 10 is 20, and that's 30, 40, 50, 60, 70, 72. And that's it. Just follow the order. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, and then we have a 7p6 over here. All right, something else, we had a couple with cations at the end. So let's just go with these guys. You had these 4 to do down here. They were a lot easier. So zinc has 30 and arsenic has 33. So let's start with zinc first. It's a 1s2, a 2s2, a 2p6, a 3s2, a 3p6, a 4s2, and a 3d10. Now this zinc plus 2 means that you lost 2 electrons. So how do we know which ones to lose? Remember that exception for transition elements. You have to lose your outermost electrons. So if we would do the Bohr diagram for this, we have our 1s2, our 2s2, our 2p6, then we have our 3s2, our 3p6, our 3d10, and then we have our 4s2. So even though 4s2 is written before 3d10, it's actually in the outermost energy level, so that's the electrons that we have to lose first. We have to lose these ones first. So the new electron configuration for Zn plus 2 would be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. You lose those 4s2 electrons. Arsenic would be a little bit different. So arsenic is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. And you knew right here that it was going to end 1, 2, 3, 4, p1, p2, p3. Like you could tell right away that it was going to end in a 4p3. This As minus 3 means that you gained 3 electrons. So where do you put them? You put them on the end. You add them onto the end. So this would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p6. I added the 3 electrons to the end. Not bad, right? So now we're going to take the rest of the period, today's a work day, to work on that electron configuration paper that's listed on the Schoology calendar. I can show you it right here. And I would like you to submit it. It's great practice, and if you have any questions, just ask. I'll be here. Now it says due at the end of the period. We'll see how far you can get. There's not that many, so you should be able to get it done by the end of the period. The reason I say yeah, you should. 16 to 20 is just seeing which one's correct. 11 to 15 is adding up your subscripts and telling what element it belongs to. And these are just writing the configurations. So you only have 10 configurations to write. And then these other things. So yeah, you'll probably get it done. All right. I'm here if you have any questions.